Welcome to Rges Algebra 2. This is section 2.3, Functions in the Real World. We have been talking about functions, probably a couple things I care about you understanding are domain and range. I think we've already actually discussed this before, but on the x-axis with my independent variable, this would be where I'm concerned about the domain. That would be the entire set of values. Let's say I'm just graphing something like that. The domain would be from the lowest value to the highest value. If they were only integers that I cared about, then they would be positive integers ranging from one side to the other. The range are from the highest to the lowest on the dependent variable. So from here down looks like to here. Maybe if I went all the way across, this one would be a little bit lower, hard for me to tell from that graph. And so that would be the range. And we always care about paying attention to the range and domain when we're thinking about any real life considerations of problems. Okay, another thing that we might run into on a graph is when we're graphing something that gets, for instance, a graph like this, when it gets closer and closer to the y-axis or closer and closer to the x-axis without ever really touching it. We call that point at which it would never touch the asymptote. And so in this graph, we have two asymptotes. If we had something like this, where maybe I'm graphing something, sometimes you'll see, like with sine functions, you'll see something that goes up like that, and then, I'm making something up here, but maybe down like that. This value right here, where x equals whatever it does, let's say 3, where x equals 3, this dotted line would represent that neither of these parts of the graph would ever touch that value. And that is also another illustration of an asymptote. Now, we are going to do your 2.3 problems, your exercises that they want you to do quickly and mentally, hopefully, on this tape. But other than that, your graphs 1 through 10, I just want you to be thinking them through, writing down what you would consider an approximation of what a graph might look like as far as its basic shape, but I am not concerned at this point about any of those details. He's just taken you through a mental exercise to get you comfortable with what graphs are representing. So just do your best on that. I'm not concerned about the details of those answers. However, let's go through on page 61 where it says do these quickly. Question 1. On which axis is the independent variable plotted? And of course that would be the x-axis. Number 2. Draw an isosceles triangle. That would be review for you, and if you not aware of that, don't worry about it. It just means that 2 sides out of the 3 are equal. So if this line from A to B and this line from C to B are equal, which is what I'm representing by that little hatch on those sides, that is called an isosceles triangle. 3% of 800. I've kind of already told you how I do these. Okay, if I want 3%, I'm going to think in my mind, what's 1%? Well, 1% would be going over 2 decimal places. So 8 would be 1%, so 24 would be 3%. I'm just multiplying it back. Okay, number 4, you multiply, that would be FOIL. Your answer would be 6x squared plus 13x. That would be minus 8 plus 21 plus 13x minus 28, the product of the last 2 values. If j is a function of p, okay, if it's a function, if something is a function of something else, then p would be the independent variable, and j is the one that depends on p. So j depends on p. And so it the question, the way they word it, which variable depends, and that variable is the j. I won't ever ask it quite like that if I ask it. Multiply 0.3 times 0.2. Well, 3 times 2 is 6, but now they're both have one decimal, so together they have 2. Okay. Number 7, add and simplify. We have 2/3 and 3/4. Well, we'll need our common denominator, which was going to be 12. This will be 8/12, and this will be 9/12, and so that will be 17/12. That does not actually simplify, but we could make it a mixed by 1 and 5/12. Either answer is acceptable, I think. All right, so number 8 says, associate the 7 and the y. Remember, associate just has to do with not changing their actual physical order, but just inserting parentheses so that these two are associated together. Solve 9. Actually, I'm going to go to the next page, give myself a little more room here. Number 9 says, might not be able to do this in your head. It says solve x minus 4 equals 13. Remember, absolute value has to do with what? It has to do with distance from 0 on the number line. So we could go 13 in this direction, and we can go 13 in this direction to negative 13. So I'm going to set up 2 independent variable sentences, equations. The first one would be x minus 4 equals 13, and the second would be x minus 4 equals negative 13. Solving the first one by adding 4, I get 17, or add 4 to both sides, negative 17. I'm sorry. Let's do that second one without so much carelessness. There we go. Add, it would be negative 9. I don't think that's right. Okay, number 10. Finally, draw a number line and graph negative x is less than 5. Well, recall, what do we have to do with an inequality sign when we're multiplying by a negative number, which we do here to solve for x? We have to flip it. So that would be x is greater than negative 5, plotting. I always like to plot the 0. Not really necessary. And there's the negative 5 on the number line. I want not equal to, but everything greater. And that's what that would look like. And everything else is to the student's discretion on this lesson.